Hello, I am Alex Kenis, and welcome to the first pre-recorded episode of the Ender series. Now, since this is the first episode, let me lay out a couple things just to kind of nip some conflict or conversation in the bud and save myself some comments. And for the benefit of you new people out here who are just stumbling into this channel and don't know what's going on. So, for you new people, the way that I do these, just so that you know, and to save you the frustration of the comments or whatever, is that I tend to take these subjects, and I don't have a pre-written script, I just have an outline, and then I ramble on it forever and ever, and then edit the video down to a reasonable length for clarity and that type of thing. So, you'll have to forgive some of the sketchy edits. Second off, for more complex or longer videos, I always put time indexes in the video description below. So that way you can either rewatch sections that you're interested in, just go to the sections you're interested in, or skip rambling sections where you're tired of seeing my stupid face, or you just already have that information and you're not interested. Also in the video description below are my support links. I don't do a whole lot of like beggy stuff for this channel, but if you like what I'm doing here and you'd like to see it continue, or you'd like to see it expanded or that type of thing, please consider visiting them down there. I also try to do affiliate links for like the gear that I'm using in the video and that type of thing. I put those down there as a matter of course, because inevitably one or two people at least will ask for it. Now, we've gotten past the new people, let's talk about this video series in particular. A lot of you might be thinking like, why everybody's done the Ender, and we're tired of seeing these videos on like cheap printers, why don't you talk about something fancy pants? Well, there are plenty of channels that talk about things fancy pants. This is not a 3D printing specific channel, this is a tech channel. So, milking the most out of budget gear is really what we're about. I'm not going to get like a gigahertz oscilloscope that costs 10 grand and show you how to use it. I will fish around for like $20 oscilloscopes and see how you can get the most out of that. And the concept of this kind of flowed from a few different places. One was my dear long-suffering wife said that, hey, maybe you should make some like simplified videos for people who are just getting on the ground floor, and then make like a separate tier of videos that are much more technical. Well, that's a good idea, and I do the, talk nerdy to me in the 5-minute data dumps and that type of thing, but I thought it would make it much more relatable if I could do like the basic introduction to the concepts in the context of a popular printer, and then I can spin that off into much more detailed theory documents with like all the math and the physics involved and that type of stuff. And in terms of people looking for like a cheapy printer, it could just be somebody who is completely unrelated to the enthusiast sector of 3D printing, and they just want something to print like tool jigs or fixtures or do some rapid prototyping or something like that, and they want to get in on the ground floor as quickly as possible and then just gussy up the printer a little bit and see what the benefits and the drawbacks might be. Also in the tradition of hardware hacking and software hacking, which is not like, hackers in Hollywood movies where I've gotten the back door, blah, 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 but more like taking something that you have and hacking it to do something that it may not be intended to do. Adding fancy pants features, unlocking fancy pants features, just making it work better, etc., 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 etc. So, that's to all you folks before you jump in and you're like, oh, yeah, Chinese junk printer, why don't you just like buy a Prusa or an Ultimaker or something like that? Or when I get into like board reviews, oh, why are you talking about like these $20 boards? Why don't you just like buy one of the new Duets? So, I did a live stream where I built the printer with as little preconceived notion about how that would go as possible. I mean, you can't really be anywhere in the 3D printing world and not know something about the Ender, but I didn't like research all the things that I may go through because I wanted to kind of like do that on the fly. And if you watch that live stream or the edited version of it, you can see some of the stumbling blocks that I encountered and that type of deal. So I'm going to break down each of the basic fundamental parts of this printer, this first one being just the outline of the assembly and the mechanical evaluation of like, the kinematics and hardware and all that type of stuff. Things like the initial performance, the electrical performance, the firmware, and the ease of use, that type of thing, those will be in other videos. So yes, I know that the firmware came without the safety stuff enabled. Yes, I know that there's no bootloader flashed onto the chip, right out of the factory. Yes, I know that there are problems with like the serial converter chip in certain operating systems. That's going to be covered in other things. So don't hassle me, bro. This printer, it seems to me like this is mostly aimed at beginners or young folks or people that are just on a budget. So for like a budget or an intro design, the attitude usually taken is like the proof of the pudding is in the eating, if you ever heard that term. Or in the case of the 3D printers, the proof of the design is in the results. That's just to say that with the budget stuff, we're looking for something that's more than the sum of its parts. Now, that's not to say that the individual parts aren't important, obviously, or I wouldn't be doing this video, but we're more like seeing in the budget sector what you can get away with and it still performs workably or admirably even, and then what may need to be tweaked or massaged to get at least a decent baseline or to get excellent performance for a particular type of printing. But this current crop of printers like the Ender 3 are much different in that they are open source, which is also one of the points of this video. I know that some of these companies over in China, thanks to people like Naomi WOOO, are taking their first little forays into the open source world and learning what that means. So sometimes they need a little bit of coaching along the way because this is a completely different paradigm shift for them. And you'd also like to say, hey, thank you all for giving this a try. The community appreciates it and recognize people for their efforts. Evaluation can be done on a couple different levels. One, you evaluate it on the intended use case. Two, you evaluate modifications for better results in that intended use case. Three, you look at modification for other use cases, unintended use cases, or tertiary use cases. And four, you could think of evaluation of like a budget system as like repurposing the parts for a different platform or a custom build or something like that. Okay, so we'll break this into like the good, the bad, what applies to budget printers in general and the general 3D printing world, and what applies to this printer in particular and to my machine in particular, because this is also about my personal experience with this printer. And then I'll also toss in a wouldn't this be nice section, which applies to both this printer and 3D printing in general. So, manufacturers take note of that type of thing. And I'll do a little summary at the end for you, a little TLDR. All right, enough general blathering. Let's get into specific blathering. We'll start off with the good stuff about this printer. The printer came very well packaged in some very nice fitted foam. Now, let me just say that this printer and a lot of printer kits, in quotes, these days are like a quantum leap over what it used to be, like with the old rep-wrap stuff and like the early kits that were just like bags of bolts. So first off, there's a whole lot of pre-assembly, and a lot of it is put into little baggies that are pretty clearly marked. There was a little bit of confusion with the directions, but everything did end up being in place. They're also kind enough to include pretty much all the tools that you need for like assembly and use. So a scraper, lots of Allen keys, a little, assumably this is a current adjustment screwdriver, etc. They've included some extras, which is nice because I definitely did drop a few bolts on the carpet. Also included an SD card. That's kind of par for the course these days, but it's nice to have, and it seems like it's a decent capacity, although not great performance, but this chart is for another video. And they included this USB SD card reader, which is very nice. And they also included a spool holder. Look, it's nice that they include spool holders in these, but I mean, this style is not the best thing in the world. I'll talk about that a little bit later, but it's nice that they include it in case you don't have anything at all. Also, as like a safety nod to the younger crowd that might be using this, they do include caps that cover any of the corners of the sharp aluminum extrusions. That's a nice feature. And it looks like we finally moved beyond the days of exposed terminals on powered supply. You'd be hard pressed to get a probing finger in here to touch anything dangerous. I also appreciated the rubber pad feet, and these are nice because you can scoot the printer around. They don't pop off like they do with some printers. And the fact that they marked the wiring harnesses with the axis that corresponds to it, that's very nice. Also, they used JST type connectors, and they disconnect at both the motor and the board, so you don't have to pull the electronics compartment apart if you need to unplug the motor to move an axis around or something like that. And there are also printed instructions in the box and PDF instructions on the card. They're a little sketchy, but we'll get to that a little bit later. In my regular usage, I never peaked over 289 watts of consumption from the power supply, which is a 360 watt supply, so that's nice. You have a little bit of headroom there. Although how much and how clean that power is, all mentioned in a different video. And I said power supply, so let me get on to some of the bad stuff on my machine in particular. Now, I posted my quickie video on the safety ground for the power supply, so you can watch that if you want. The way that you would check this is take a probe and attach it to your safety prong, and then find a piece of metal that is definitely attached to the housing. And if you have a very low impedance rating, a very low resistance, then you're good. If you have an open circuit, obviously that's bad. And remember that there is some kind of insulating housing on the aluminum of this supply, so you might have to probe a bolt or something like that that's threaded in. Also, one of my screws popped out of the cooling fan and managed to make its way into the fan shroud here during shipping, which knocked off one of the blades. Actually, it broke one of the blades and I pulled it off just so I'd be able to print, which, as you can imagine, led to some horrendous vibrations like you can see here. Also, one of my bed adjustment knobs popped off in shipping and managed to wedge itself into the foam packing so that I couldn't find it during the live stream, but I did eventually locate it. The Bowden coupler in mine was also not great. You can see right here there's a lot of flex. So what that means is I marked this here with a little Sharpie so you can see that pulling in whenever it does a retraction. So that makes the whole connection a little bit spongy, and you would have to add extra retraction length to that. Now, these couplers are not inherently made for this type of thing. These are pneumatic couplers, and even from the same batch, one might work and one may not. You never know till you try, unfortunately. And speaking of the tube and couplers, when I printed a full volume height cylinder, I got a little bit of under extrusion up at the top, you might say. Okay, it's a lot of under extrusion up at the top. And that was due to the angle of the Bowden tube pushing against the top support and then scraping on the filament. Now, this is a common problem because, as you can see right here, like I said, these are for pneumatics, not for something passing through it. So it's a kind of hex shape on the inside with a lot of sharp edges that your filament can catch on. So I have a little modification that I usually do to these Bowden couplers, and I'll mention that in one of the modification videos. But as you can see right here, I basically just smooth it all out and ream that hole in the middle out a little bit more so that the filament passes through without scraping. And to test the kinematics, I just did some drive movements, like i.e. without any extrusion or heating up the hot end or anything like that. It was just like a spiral vase that went all the way to the top of the printer. And I just did that like you would with any other spiral vase in Cura, and then just turned off all the extrusion stuff. Oh, P.S. If you're using Cura, the new interface sucks, so do yourself a favor and go to Marketplace and then install the sidebar GUI that gives you this nice pane over in the right that you can work on. It's better for workflow and conducive to, actually getting any freaking work done. One of the benefits of doing like dry movements to test is that you can hear what's going on with the printer because you have the fans turned off. And I noticed there that my belts were rubbing, and you can hear that right here in this clip. Also, my bed was not perfectly flat. As I mentioned, it dipped a little in the back, so you can see that from where I just printed this cylinder right here, and I had to sort of level that out as I went. It wasn't unprintably terrible, but it was a little bit bent. Fortunately, it has a pretty grippy print surface on there, but as you can see, it's already starting to wear down a little bit. These types of surfaces are not my favorite thing. First of all, you don't really need them for PLA, and this scraper is kind of insufficient for getting it off, so I end up using like the razor blades and a little bit of rubbing alcohol. I'll cover testing of alternative print surfaces in a future video. So let's move beyond just the issues on my printer and talk about issues that you should be aware of that are common to all Ender printers in addition to the previous section. But let me talk a little bit about quality control, because in my endeavors over the years, I've worked as a service manager for a couple different places. And as part of my job, I had to revamp or develop, in some cases, the quality control measures for the service coming out of the places that I worked. So the important things that I found were A, take out all the variables, B, accountability, and C, redundancy. Like, those were the three biggest things. Taking out all of the variables means developing just a simple checklist of the major things, and that can go through revisions as you're finding different things about the products that you're sending out or servicing or whatever, so that you have to make sure you add that to the checklist to check. And it could be just, 5 basic things. Hey, check the safety ground, check that everything's screwed in properly, you know, that type of stuff. Second is accountability. So just something as simple as having someone initial the bottom of a checklist keeps them accountable to it. It also lets you know whether or not it was done if they went down the list and signed it. Now, sometimes you'll have the lazy, sketchy people that will not actually do their proper quality control check and just sign off on it, or they could miss something. So redundancy. Have a second person double check their checks and sign off on it. Now, I know a lot of these places, they'll have like a little signature for like quality control or like a sticker or something like that, but it doesn't actually seem that they checked anything. For example, those power supplies, like there was a QC seal on it and like a date, but obviously they didn't even take a multimeter, check the safety ground, and then check to make sure that the case was grounded to it. Otherwise, you know, 3 seconds with a multimeter would have pointed that out. So that's just goes into like the perception of brand quality and that type of thing. Okay, so back to what we can do with our printers. You can pretty much just run through like your own quality control checklist. For example, check all the third-party parts. So like the power supply, the Bowden couplings, check the wheels for flat spots, all those types of things. Also, something that I don't really like is using just simple friction to hold together to resist like shear and torsional forces, because the tension of those bolts holds friction of the gantry against the Z-axis plate, as well as using the same type of a deal for holding the adjustment of the belt tension, as well as the belt tension and the whole motor assembly. I would prefer both a finer like screw type adjustment to take up that slack, as well as something that's more rigidly coupled. Now, if I may be so bold as to use a printer that I designed here, if you look at the gantry, this was meant to use linear rails. So the X gantry is actually resting on bolts that go into the linear rail cart, and so that's not freaking going anywhere. Then up top, we have a couple of bolts that hold that against it so it doesn't move, and then over on the other side, there's a fifth bolt, I should say, that bolts straight through and make sure that everything is straight and flush and pulled all the way against the back. It's not a huge deal, but I would rather they have adjusted this out of the factory so that it would always be perfectly square and aligned, rather than having to fiddle with that whole process and worrying about just the tension of these plates against each other holding your adjustments. And I said squaring and alignment, which to me was the biggest issue with the assembly of these printers. They don't have a procedure, and I don't know how they can reasonably expect you to do that out of the box. I've seen some absolute horror show pictures online of people trying to debug prints, and then they show a picture of their printer and their gantry is racked at this ridiculous angle. So I won't include it in this video because it's going to run a little long anyway. I'll have a completely separate video for the procedure and modifications that I did for keeping squaring and alignment, or I guess you would call it tramming in like the CNC world. And I'll include some alternative methods as well that were suggested by viewers of the live stream and other people online. Also, I mentioned that my Bowden coupler was a little bit spongy, but the scraping issue is probably going to be an issue on a whole lot of different printers, which again is one of those issues that like can give Bowden printers a bad name, but it's a real simple fix, and I'll put that in a video as well. Another thing that I'll address in yet another issue is how freaking springy these springs are. They don't have a whole lot of tension. Right here, you can see that the power supply shroud, although it's nice, it's a little bit flimsy, especially if you're pulling out that 3-prong connector and plugging it in again and again. It's probably going to crack, so use both hands. Also, if I can be pedantic, I mean, this switch is upside down, technically. I mean, down is usually off. That makes the most sense. And although the wire harness is nice and they do have this coating on it to keep them from, abrasion from causing the short out or something like that, it is a little bit messy. It's easy to set your printer on top of them, and you have this little ribbon cable underneath that moves back and forth and can easily rub on your bed as that's moving. Another thing we'll cover in some modification videos, this belt seemed particularly flexy for me. I didn't take it off and cut it up, obviously, because it has little grommets on the end, but I will be doing that in a future video, and we'll look into why those feel so flimsy. As far as the cold end, there isn't any tension adjustment, so you just kind of have whatever tension this spring is, squashing your filament with the pinch wheel against your feeder gear, and the feeder gear is not great. It's not terrible, it's fairly sharp, but it is brass, so it will wear out quicker than like a hardened steel. And it would be nice to have a tension adjustment there so you're not causing your extruder motor to have to put out additional torque just because it's pinching too tight. If I could be nitpicky, they used smooth bearings as rollers on the toothed side of the belt, which is not my preference. I don't know if there's really a big difference between using a toothed or a smooth, but I much prefer to use the tooth rollers. And as I previously mentioned, I had flat spots on my wheels from them being tightened down and then sitting against the rail during storage and shipping. It wasn't a huge deal. It doesn't appear to result in print artifacts, but they are there. This shroud is fairly flimsy and it does vibrate a bit even with a decent fan on it. And let me stop this really quickly and I'll show you some experiments I did with a fan. I took my kind of off-balance fan as an opportunity to show you the artifacts that you can have on a print in particular setups when you have a fan that's, you know, suboptimal, has bad bearings, is kind of not balanced and that type of thing. So I did a print of just like a spiral oval with the fan freaking out, and then I just stuck a bolt back in there to stop the fan, and I used just a handheld PC cooling fan to make sure that the hot end didn't overheat and jam up the filament while I was doing this, and then tested that for the quality versus the other way. And you can see right here the result of the vibrations the fan having on the print. And this is also what it looks like under a microscope. So the center section is where I had the fans off, and then the other two sections were where I had them on. And you can see the obvious ripples from the vibration in the print. And you can compare that to the nice smooth lines off of one of my other printers. So I wanted to isolate all the fan vibration from the system completely, so I popped this shroud off, and then I took some VHB tape and I mounted the entire like cooling fan selection to that so that it would be fairly decoupled and damped by the viscoelastic effect of the foam. I also took some little rubber grommets or spacers or whatever, washers, whatever these are, and I isolated all the other fans, isolated the power supply which has a fan on it, and the fan in the electronics housing as well. And as you can see, the layers are much smoother. I should say the extrusion is much smoother. So that's just a nod to using decent fans or mounting them in a way that they are decoupled from, you know, anything that's going to cause the hot end while it's extruding to vibrate. And yes, I will be looking into cooling fan options in another video. And moving on to other things that could cause print artifacts, this type of spool, like I said, I did not use this. I don't like these wamble back and forth type of spools, because when you have that motion back and forth, when it rocks and you're pulling it with an extruder, it's very possible that it can tug backwards in the reverse swing and cause under extrusion at certain parts. So, not wanting to waste filament, I decided to just knock up my own spool holder to mount on this, and I used that as like a long-term print supply to see if there was any kind of like hot end heat creep. It took like 13 hours or something, and it turned out pretty well, actually. My personal preference is to use ball bearings and constrain the movement in every axis except for rotational, and then to be able to have a tension adjustment just by putting additional side pressure on those bearings. Oh, and by the way, this is the filament that I'm going to be using for all these tests. It was like super budget sale a little while ago, so I bought a bunch of spools. And then just one more thing I should mention with the electrical stuff, there's these XT60 connectors, and people either love them or hate them, depending on what you're doing. I have a bunch of these around because they're commonly used in like robotics and whatnot for quick disconnect like power supplies. They are meant to carry a lot of current if you attach them properly. These in particular are meant to be soldered on, and apparently in some early models they were crimped instead of soldered. Crimp-on power connectors are fine as long as they're designed to do that. Otherwise, you're not going to get proper surface area contact. You're going to get a high contact resistance, and then in accordance with Ohm's law, you're going to have your connectors heat up and either melt down or catch fire. Mine were actually fine, but I didn't like the fact that it didn't hold as tightly as these types of connectors usually do, so I did stick a little screwdriver in there with everything powered down, of course, and just spread the prongs a little bit so that they make more positive contact and keep from, you know, popping that out accidentally. But some general thoughts now. Here's where I'm going to cover some things that would be nice for this printer and for the industry in general. And I'll ramble a little bit on some of these, but hit some things that I've just come across in all of my use and all of my discussions of printers and that type of thing that I think would be nice. Better cooling design and better fans. Now, I already showed you the section where you could see that with off balance or cheap or defective fans, you can get bizarre printing abnormalities that is going to play into the customer's perceptions of your product. Same with the cooling. Now, this was much more of an issue back in the early days, but even now, like, good cooling that you've tested the design on these printers can make or break the perception as far as like general users and their first impressions of prints and things like that. We know that if you have adequate cooling with PLA, things look nicer, bridges look nicer, details are sharper, that type of thing. Now, technically this next one is met by this printer, but a safety ground for the frame in general or anything that you're going to be interfacing with on the printer. The safety ground is so that if you have some kind of, short to chassis, you don't get an electrified metal enclosure that then completes a ground circuit through your finger and to ground, thus giving you an electric shock. And believe me, with some of the other crazy mad scientist things that I do, I know the importance of a safety ground. This one has 600 volts on it. So if the safety ground were properly attached on this printer, since the power supply bolts into the frame, then anything bolted into the frame is also going to be safety grounded. But since it's not, anything that happens with the power supply is going to be coupled into the frame as well and give you a shock. But I have seen a lot of printers where there is a separate power supply, no particular safety ground to the machine, and then they use like a mains power supply, like silicone bed pad or something like that, which I wouldn't do. Also, please include shorter test prints on the cards, something that you've developed as like a couple little gizmos and thingy-doos that people can like do in, you get a lot of mileage, 3D printing companies, out of YouTube channels, like evaluating your printers and doing live streams and things like that. But all the prints on the card take so long. I printed the little dog, where is it? The little dog monster thing, which was actually a really nice print. Let's see if it could, nope, it's going to be totally washed out. But this took like 6 hours, so obviously you're not going to do that on a YouTube video. And you don't want that to be your first experience with the printer, is just slowly watching this build up over the course of 5 or 6 hours. Along those lines, it'd also be great for you to pull down some like calibration and testing demonstration prints. You could even use that as like, a selling point, say like, hey, look how great our printer does in these test prints that we included. Like overhangs and bridges and small lines and things like that. Cut that up, slice it up, put it on a card as G-code, and then have that as one of the test prints. And while I'm talking about cutting things up and configuring software, most of these machines work off of some version of Marlin. And usually the first step that people do, if they're going to be modifying these or messing with the controls, is to download just vanilla Marlin, configure everything themselves, and flash that to the machine. Now, I know that you can go into Marlin and you have user contributed profiles. There are Ender profiles, and Marlin have most everything set up, but it would be nice to have that with the machine. And I know a lot of people are moving that way, but typically they will have like 1 or 2 options, or maybe just like the base option, and then if you have it with like automatic bed leveling or something like that. But companies like Creality and others, they have like entire ecosystems they want to sell you, and there are various options for that type of thing that you actually have to go talk to people on like Reddit or, the Marlin GitHub or something like that, configure the options yourself in the firmware, compile that and upload it to the machine. So if you want people to buy into your whole ecosystem, you should probably have profiles set up for all those variables. Or, and this would be fantastic, if companies would make a front end for configuring the firmware for their machines and ecosystems. It's not a tough thing to do. You just have to have somebody do it and then maintain it. It's easier for much more closed down, or I should say narrow in scope systems like, RepRap firmware or SmoothieWare or something like that, where they're really just dealing with like one family of boards and one family of processors and their peripherals that they sell you. because you can easily do like a web interface with a couple pull down menus. I understand it's tougher for Marlin, but we are narrowing that scope of like something that's as wide and configurable as Marlin, and then you're just talking about using that with a particular series of printers. So you could narrow down the options significantly and give a much slicker front end to it. And speaking of beginners, a very simple like beginner type guide would be nice for like print surfaces and temperatures and types of filament. A lot of these places, like they will, in addition to selling 3D printers and peripherals, sell their own branded filament and that type of thing, usually of different types of composition. It would be nice to have like Cura plugin profiles for your machine, for your particular filament, and that type of deal. Again, not very tough. You could have somebody do that in like a day or two, experiment with different options on how it prints, and then like have an optimized profile for your machine. And then finally, and this is the most important for this machine, getting it running out of the box, is like a squaring and alignment and initial setup guide. There's instructions on assembly, but then it's just kind of like, oh, yeah, you're good to go. Now go ahead and print your 5-hour-long dog. So yeah, it would be nice to have a squaring and assembly guide and pre-first print checklist, that type of deal. All right, so let's sum this up as best I can. So the good, the meh, and the bad. So for the good, the printer definitely lives up to its reputation as like the champion of bang for the buck printers. There are thoughtful assembly touches like the little pre-bagged components and the tools that they include for everything that you need. It's also a nice kind of Spartan simple design that leaves room to grow. It's your basic like, i3 type of a design. But the use of the like open builds linear rail type deal and the minimalistic hot end mean that you have a lot of room to work on and bolt things on. And even as is, the results are pretty good if you're doing like low to moderate speed printing for like normal types of things. I'll get more into like initial configuration print quality in other videos, but it is good. Otherwise, it wouldn't be nearly as popular as it is. So yeah, I think it's a solid like first printer, learner's printer, or like secondary printer if you just want something you know is going to be decent out of the box and you don't have to worry about it and you're not looking for something that's, super fast or super fancy or whatnot. And it does make a good modification platform because of the open design and the fundamentally decent parts. So they didn't cheap out on things like, the lead screw is pretty good. I didn't have any problems with mine. I understand some people have binding on that Z-axis, and I'll talk about that in the alignment video. But if you set it up properly out of the box, I didn't have any fundamental flaws with like those things. The motors were good. They're not, super fast or super powerful, but for this size of a printer, they're adequate, and we'll get to those as well when we start talking about like modifications and things like that. It is easy enough right out of the box that like a kid could build it with their parent. And there are minimal like deal breaker issues. Some of these printers that were kind of popular had like big deal breaker issues, like a super faulty whatever. But the meh, it's not truly a child safe printer. I'd say it's like a good like youth or adolescent safe printer. But the fact that it does use an exposed metal chassis, even though it does have that kind of conformal coating on it that insulates it somewhat, there is still a possibility because of the bad safety ground quality control from whomever they source those power supplies from. I did look it up and I do have the data sheets, but we'll save that for another video. But if I were trying to design a child-safe printer, I would make sure that there's nowhere that probing fingers could get in and get caught in a belt or something like that. There's no way that they could unplug anything and expose themselves to dangerous wiring. And I would make sure that I would probably use a isolated power supply, like a medical style power supply with galvanic isolation from the input to the output, as well as an encapsulated chassis, kind of like the power supplies you get, that they put with you things, like your Xbox has like a 203 or 220 or whatever watt enclosure. Your like Alienware laptop would have like a 300 and some watt power supply. And the instructions do leave some glaring questions. If you remember from the live stream, like I did put some axes together backwards because I just didn't realize how literal some of the pictures were being, and I didn't, have time to go through and look at everything first before I put it together. You can avoid some of those issues that way. The squaring and alignment procedure doesn't exist. So like I said, I'll do a whole separate video on that, the way that I did it and the way that some other people do it. But to conclude the meh section, you'll outgrow this printer pretty quickly if you really get into like 3D printing. You'll find its limitations. Now, that's definitely going to vary from person to person, which is why I prefer these really kind of like minimalistic, moddable platforms, because you can kind of build it into what it is that you need. Like, do you need faster prints, or do you need taller prints, or do you need to use like a high output extruder? They're different, completely different from person to person. So I do dig minimalistic, cheap platforms that are solid on the basics, and you can do what you will with it to make it the machine that you need. Okay, now the bad. So I've mentioned the power supply issue, which is a part that is sourced from a third party, and hopefully they would either go with someone else or approach that manufacturer and say, hey, make sure when you put a quality control seal on it and you have, CE and UL and certification and all that stuff, that you actually do the quality control and pass those tests. I can't imagine there was any kind of testing going out of the door if they didn't catch a bad safety ground. But as far as the bad, there's not a lot bad with the machine itself. There's some, like meh bad with the machine itself. Like I said, you're going to run into the limits of like the board, and if you go to like reflash firmware, you're going to find all the issues that are there, and I'll cover the firmware and the software, all that stuff in a different video. But mostly it just boils down to quality control, which is kind of to be expected on like entry-level, low-cost printers, but just another layer of quality control would really nail things down. So like the bolts being either too loose or being over-tightened, like the wheels being over-tightened and having flat spots from, sitting in storage that whole time, the power supply issue, the couplers on the Bowden, my bed being a little bit wonky, like that type of stuff. If that were tightened up, even if they had to add like another, $20-30 to the price of the printer, that's well worth the cost, I would say, in terms of like brand reputation and printer reception and reviews and ease of use and like all those things. You got to think about those like non-tangible returns on investment in terms of like quality control, but I digress. That's it. We're done. We made it to the end. Thanks for watching that video. Like I said, we will be doing many of these in the future, and I'm using the Ender as a springboard to introduce a lot of different 3D printing concepts. So if you're not particularly interested in this series of printer, but you are interested in something like options and testings with different hot ends and print surfaces and that type of thing, that's all going to be rolled into this series and to show up in future videos. If you dig this type of stuff, check out my support links in the video description below, and like and subscribe and ring the bell and blah, 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 blah. Thank you again, and until the next video, get out there and make something awesome.